Hello students, I'm Professor Benavides and I want to go ahead and give you a summary of Chapter 3 modules. I want to go ahead and drill down on focus on languages, specifically the Python programming language. Now this is Chapter 3, it's all about modules. Last time, Chapter 2, we talked about input processing and output. We learned about the input function. We learned about variables, which is places in memory. And then we learned about output using the print function. So now we're going to go ahead and drill down on modules and see what all that's about. So this chapter discusses modules as named groups of statements that perform specific tasks in a program. You use modules to break a program down into small manageable units. In Python, we use functions for this purpose. In Python, the term module has a slightly different meaning. A Python module is a file that contains a set of related program elements such as functions. That sounds a little confusing, but let me try and break this down. We're going to go ahead and talk about ways of making programs that get big into more of a manageable way of dealing with them. We can do that by using something called functions. Now, when you use the word modules, let's don't confuse that with modularizing, your program. A module in Python has a very specific meaning. We're not going to see it in this particular chapter, but it's a file that contains a whole bunch of functions that you can go ahead and then use. That's how Python uses that word. Let's move on from that and continue to talk about functions. So how do we define and call a function? Here is the function definition, and there's an example code there below. Now, I'm going to go through these slides and talk about the concepts, and at the tail end, I'm going to go ahead and bring up a simple text editor and type in some code to hopefully bring this chapter to life. So for right now, let's look at something called the function definition and see how that relates to writing a function. So to create a function in Python, you must write its definition, which consists of a header that specifies the function name, a block, which is a collection of statements that are performed when the function is executed, and all statements in the block must be indented. So here is the general format. We start off with the keyword def, then we have the function name, followed by the statements. Here's the example encoding, the def keyword, which stands for definition. In this case, I'm going to name my function message. It must have an open and closed parenthesis, followed by a colon. And inside of this function, I'm going to have two simple print statements. So how do we call the function? One thing you need to know is that if you don't call it, nothing happens. If you have a function that's been fully written and you run your program, again, nothing will come out on the screen unless you actually call it. So there's two things that we got to be aware of. We've got the function definition and the function call. So when a function is called, the program branches to that function and executes the statements in the body. Then when the end of the block is reached, the interpreter jumps back to the part of the program that calls the function, and the program resumes execution at that point. When this happens, we say the function returns. So here's our first example of a function definition and a function call. Message with the open and closed parenthesis used by itself is the function call. And there's the output, which is the result of the two print statements. So again, let's be very, very clear what happens here. If you've got your function definition and you run your program, nothing will happen. What is happening here? So when the Python interpreter reads the def statement, a function named message is created in memory containing the block of statements in it. A function definition creates a function, but it does not cause the function to execute. Next, the interpreter executes the function when it gets to the function call. This causes the message function to execute, which causes the 2 lines of output. Inside this function definition, it is vital that we have indentation. Why? Because that is how it knows when the function definition, or where the function definition begins and ends. In this example that we see here, we've got a function definition, and then we have some lines of code below it. And it knows, the interpreter knows that those last 2 lines are not part of the function definition because they are not indented. Now, thing to remember about indentation is that you must have the same number of spaces when you indent. So if you're copying and pasting code from different programs, they must all be or have the same number of spaces for your tabbing. Local variables. So local variables are variables that are declared inside the function. Later on, we'll compare that with something called global variables. So what are local variables? Variables that are declared inside of a function are local. Statements outside the function cannot access the function's local variables. That brings us to the concept of scope. So a local variable scope is the function in which the variable is created. In other words, you can only access it. Its scope, its use. You can go ahead and use it, access it, print it only from within that function. It is local. Passing arguments to functions. To pass an argument to a function, you must declare a parameter variable in the function's header. A parameter variable will receive an argument that is passed when the function is called. So here we have our definition, starts off with the keyword def, then the function name is double_number. Value is the parameter variable, and of course the header line terminates with a colon. Inside the function definition, we see that we have 2 statements that are indented. So result gets value times 2, and then we simply print result. When we pass arguments, we must understand some key words here. We have arguments, and then we have parameter variables. So here you see at the top, you've got double_number 5. 5 is an argument. It is being passed to value. Value is the parameter variable, and the parameter variable is used inside of the function called double_number. So the idea is this: if your function definition has 1, 2, 3, parameter variables, you would pass it that same number. See, in our first example, we had a function definition, and it didn't have, any parameter variables. This is a parameterless function. Then we use our next example here, or in our next example, we see it has 1 parameter variable, so we must pass it 1 argument. Then we come to our first little example, and let's walk through this, in our heads, and then I'll type it in for you in a little while. We'll drill down on it. Now, this first example uses the main function, which is not something typical that we find in Python. You typically find the main inside of C or C++, the Java programs. It's simply a way of organizing our code. Okay, think of it that way. So let's go ahead and I know the topic is passing arguments, but it does have something else thrown in here that we need to explain. So the idea is this, that the action occurs inside the main function, okay? And in Python, the main function needs to be called, and it is called on line 11. So when the program is executed here, it reads everything into memory, goes to the last line, main is then called, flow of control comes up to line 2, and it calls double_number, passes an argument of 4, and in that particular case, the flow of control goes to line 6, 4 goes into value, value is multiplied times 2, and then the answer is printed on the screen. Of course, the answer is 8. Okay. What if you have multiple arguments? Well, in that case, you got to be really careful about, excuse me, what if you have multiple parameter variables? Or in your definition, if you have multiple parameter variables, you must pass it multiple arguments. Okay. In this particular case, show underscore sum has 2 parameter variables, num1 and num2. In that case, you must pass it 2 arguments. So these arguments are passed by position to the corresponding parameter variables in the function. In other words, the first argument is passed to the first parameter variable, and the second argument is passed to the second parameter variable. So 10 goes into num1 and 20 goes into num2. Arguments are passed by value, and so in Python, only a copy of the argument's value is passed into a parameter variable. If a parameter variable is changed inside the function, it has no effect on the original argument. Let's see that in code. So in this particular sample, we've got our function definition on line 7 called change me. It has a parameter variable called args. Okay, so going to main, I see that 99 is assigned a value, and I print out the value 99. The value is 99. Then I call change me, pass 99 to it. And inside of that function, 99 goes into args, but then I assign 0 to args and I print it out. I say now the value is 0. But then the flow of control goes back to line 4 and then to line 5, and it says back in main, the value is value. So what happens here is it prints out the 99. That goes back, and let me reiterate what I just said here, is that in Python, only a copy of an argument's value is passed to the parameter variable. If a parameter variable is changed inside a function, it has no effect on the original argument. That's why, see, if you'll notice here, we passed 99 to the parameter variable. We then assign 0 to args, and then we then come back to main and print out the value, and it remained 99. Why? Because we only passed it a copy. Okay, so thing to remember here. Remember this. This was passed. We passed a copy of it before. We talked about. Don't get it confused here. These were passed by position. That means that the first argument goes into the first parameter variable, second argument goes into the second parameter variable. That's different from passing by value. Passing by value means that only a copy of the argument's value is passed into the parameter variable. Global variables. In Python, when a variable is created by an assignment statement that is written outside of all the functions in a program, the variable is global. VIP, a global variable can be accessed by any statement in the program file, including the statements in any function. So let's look at the example below here. Now, if you look at the very top, my underscore value, that is a global variable. Notice that it's not inside of any function, right? It's not local. It is global. Okay. So in this particular case, it works out just fine that we were able to then access my value from inside of show value. The thing to remember here that an additional step is required if you want a statement in a function to assign a value of, if you want a statement in a function to assign a value to a global variable, you'll have to have an additional statement. So what will you have to do on line 5? You'll have to go ahead and use the keyword global. And I will show you this in code, but let's look at this just briefly here on line 2. You'll notice that I assigned 0 to number. That's our global variable. Notice that it is outside of any function. So inside of main, line 5, I go ahead and use the keyword global, and then I ask for input into number, which is then the assignment goes into number, and then I show the number. In that particular case, yes, if I enter in 22, the number you entered is 22. So that is how you go ahead and update the global variable. You must use the global keyword. Global constants, Python does not allow you to create true global constants. However, you can simulate them with global variables. The key is this: if you do not declare a global variable with a global keyword inside of a function, then you cannot change the variable assignments. So in other words, going back to this assignment here, if I don't do line 5, then in that particular case, even if I ask for a number and then show the number, it's still going to show 0. Okay, so that's my rendition of this chapter. What I'd like to do is I'd like to go ahead and do some live code demonstrations of the things that we talked about. I'm going to go ahead and launch a very simple editor that's used a lot in for Python. It's called Wing 101, and you can just it comes in several versions, but this is the simplest one, Wing 101. And I want to start off with type it in. I'm going to use a file that I've already created called demo.py and just type in everything in here. Let's talk about defining and calling a function. So first of all, let's go ahead and start off with a function definition. We start off, with the keyword def. I have to make a correction in my PowerPoint that I just noticed. So we'll start off with the keyword def and then the name of the function. And then we have the open and close curly brackets and then the colon. When I press enter, I can then enter in my statements in. So I will then go ahead and say, I am Arthur. And then another print statement. All right. So if I were to run this right now, nothing's going to happen because I haven't called it. So let me just prove that to you. See, I run it, nothing happened. What is missing here? What is missing here is the call. Okay, now if I go ahead and press enter here and then I don't indent properly, let's say I call it, or I attempt to call it. Let's see what happens. Well, nothing happens. Well, because see, this indentation is what is necessary in Python so that it knows when the function begins and when it ends. So message needs to be flush left. I'll go ahead and run it again so that it's outside of that suite. Remember, the author called it block, but Python people call it a suite. So I said, I am Arthur, King of the Britons. So here we have on line 1, we've got our function definition, and on line 5, we have our function call. Really important that we understand that distinction between them. Indentation, very important. The thing to remember here is that you must have the same number of tabs if you're copying and pasting code from different files. So let's talk about local variables right now, and we'll contrast that with passing arguments and stuff like that. We'll talk about local versus global and all that kind of stuff. So I'm going to go ahead and create another function here. I'm not going to call this. I'm going to get rid of this call, but I'll just create another function. Leave that one there, and let's call this my functions. My function, right? And in my function, I will set this to a value of 5, or assign 5 to value, and then print. And of course, if I were to run this, nothing will happen, right? Let's just prove that nothing happens, right? Because I have not called it. So if I call it, it shows 5. Now, so this is referred to as a local variable. If I were trying to access it outside of there, let's say I want to go ahead and print value and run it. it's going to say, I got to trace back, and it says line 10, name value is not defined. So it can't see it. So scope. So local versus global is the concept of scope. In other words, where you can access the variables. This is local only to this function. It can be used only with this function. If I try to use it outside of the function, I'm not going to be successful. Okay. So that is the concept of the local variable. As far as passing arguments, let me go ahead and create another little demo on here. So we'll say def double number. And I'm going to go ahead and say result gets value times 2. And then I'm going to print result. Okay, so in this particular case, notice how the idea here, this is called right here, value is a parameter variable. So that when I call this, I have to match up. If I've got one parameter variable, I pass it one argument. If I got two parameter variables, I pass it two arguments. I've got to match up on this. So when I call this, and I pass it an argument, so 5 is an argument, it's going to go into value. And in this particular case, 5 times 2 is 10, and then it prints 10 over here on the output window here in the shell. Okay, so that's passing arguments. A lot of times people will do things like this. They will forget to pass an argument. So if you run this, you'll notice, let's look at the traceback. It says, I've got a problem on line 13. And it tells you that double number is missing one required positional argument. Because remember we said that they're passed by position. So the first argument goes into the first parameter variable. The second argument goes into the second parameter variable. So we can go ahead and do this in a more modular kind of way. One way to do this would be to go ahead and utilize the main function, which is not very typical in Python, but if you're coming from C++ and Java, you may be interested in this idea that I'm going to show you. So the first thing you're going to want to do is we're going to go ahead and define the structure of our program. And I'm going to just go ahead and tell you those parts here. You've got to have the main function, a function, maybe another function, and then you have to call the main function so that it knows where to start on here. So let me go ahead and start off by creating the other function that I have in this program. So we're going to have double number. I probably should have left that one on there, right? So anyway, I'll do it again. And result gets value times 2. And then print result. All right, so as we know, nothing happens if I were to run this. Let me prove it to you. Nothing up my sleeves, my friends. So let's go ahead and call that. Instead of calling it, I'm going to go ahead and call it from main. So we'll say def main. And I'm going to pass it an argument of 4. Let me run this and show you it's not going to work because we have to call main. So nothing happens, right? Believe it or not, in Python, we have to call the main method. So in this case, at the very bottom, we'll call main. Run it again. So the answer is 8. So when we call main, flow of control comes here to line 1, and then it calls double underscore number. We have one argument, that is passed into value. So 4 times 2 is 8, and it's printed on the screen. As far as passing multiple arguments is concerned, we can we have to remember that go ahead is that for every parameter variable you have to match it up with an argument. So this particular example, let's say show number or show sum, excuse me. We've got two, in this particular case, two parameter variables, and I'm simply going to add them. And I'm going to print the result. Okay. This particular case, I'm going to call the show sum. And of course, that's not going to work because I forgot the keyword def. Probably should have run it. I always like to run after I create the definition, so just to make sure that it's you always know you've got the right number of indentations. You go right to the end of the colon and press enter, and it takes you right to where you need to be. Okay, so in this case, we're going to call show sum. And then when I put in the parenthesis here, I have to think a little bit. You know, if I've got 2 on there, I've got to pass 2. So I pass 10 and 20, right? And in this particular case, then I'm going to go ahead and run it. And it's got 30. Okay, very good. All right, so let's look at the parts on here. Here is the function definition. I have 2 parameter variables, so that when I call it, right here on line 2, I must pass it 2 arguments. Right? So these arguments are passed by position to the corresponding parameter variables in the function. So let's talk about making changes to parameters. The idea is that only a copy of the argument's value is passed to the parameter variable. Let's go ahead and do a little example, of this. I'm going to go ahead and make another little function here. Let's call it change me. And I'm going to go ahead and give it a parameter variable of arg, for, I guess that's short for arguments. In this case, I'm going to simply print I am changing the value. And then I will go ahead and say arg gets 0. And then print now the value is. Okay. All right. So coming over here, as far as the rest of the logic on here, let's say that I assign 99 to value. And then I say print the value is. And then I call the function change me, and I pass it. What do I pass it? I'm going to pass it value. And then come back and make a print statement. And let's go through the logic. I'm going to get rid of the other functions so that they don't detract from the main idea here. I need main. Okay, so here's our function definition here, change me. So it has 1 parameter variable, right? I say I'm changing the value. So I assign 0 to arg. And then I say now the value is, well, it's going to say 0, right? But when the flow of control, remember the action starts in main, I assign 99 to value, and then I say the value is 99. So it's going to say the value is 99. Then I pass 99. I pass 99 in here to the function. Then I assign 0 to that, and it says, hey, I assigned it to 0. But then the flow of control is that after I call this function, the flow of control comes back to line 4, right? It returns, remember? And then it prints this last line, which says, back in main, the value is. Okay, so let's go ahead and run this. So the value is 99. I expected that. And then I changed the value. So now the value is 0. But then back in main, the value is 99. Excellent little demo about the fact that in Python, only a copy of an argument's value is passed into the parameter variable. Okay. Now that brings us to the concept of global variables. And let's go ahead and do a little demo of this. Global variable would be something outside of every function. So in this case, let's say my value. And I'm going to set that to 10. So that is a global variable. It's outside, right? So I'm going to go ahead and create a function called show value. Show underscore value. And inside of this, I'm going to simply just say print value. Okay. I'm going to get rid of this so it won't confuse what we're doing. And come back in here into main. And go ahead and inside of main, this is where we simply call show value. Okay. All right. So again, to repeat, on line 1, I've got my global variable. Then inside of main, I call show value. Show value simply prints the value, right? So let's go ahead and see what happens here. And I've got a little, I've got a few problems right here. So let me go ahead and take them in and see if I can figure them out. Let's see now, tracebacks. Name value is not defined. Oh, of course, value is not defined. It's my value. Okay, so let's go ahead and my value. And go ahead and run it again. And the value is 10. The output is 10. This is again a line 1, a global variable. Now, an additional step is required if you want a statement in a function to assign a value to a global variable. Okay. So again, an additional step is required if you want a statement in a function to assign a value. All we did here was print out. We assigned it up there on line 1, but let's say I want to change that inside of, you know, here, like for example, on line 7, you know, let's say that I want to go ahead and change that. Or before that, let's say I want to change my value and change that to 0. What do you think will happen? Okay, so what happens here is that 0 is assigned to my value. This is local. Okay. So we want to go ahead and do the global idea here. So let me go ahead and show this, and I'll contrast these two ideas here. So let me go ahead and get rid of that design, and we'll start the new one here. So number gets 0, and then we'll have our our main. And I probably should define our show number. And then our main. I'm just getting the overall structure, and I'll come back to it. Okay, that's the overall structure. I want to define this one first, the middle one. Print. Okay, and then in here, then we'll say global. We've got to use the global keyword. Number. And then we'll say number gets input, enter a number. Don't forget that space afterwards, otherwise it looks awkward. And then we'll just repeat this again. In this case, pass it to the int. And then call show number. All right. So in this particular case, I assign 0 to that. And I enter in a number here. And since it's global, it should update. It looks good. So let me go ahead and run it again. So enter in a number. Well, number's already been assigned 0. If I go ahead and put in a 10, it says the number that you entered was 10. Okay, so it was updated. The first example, I don't think I did it, went through that good because it was an assignment statement on here, and it was mixing up the local concept with global. So I apologize on that. So let's zero in on this one here. In this particular case, this is global. It is not local, which the other one was. It was overriding it. So in this particular case, it's working just fine. So that's a global variable on line 1, and the key word here on line 4 is global number. So then that brings us to the idea of global constants. Python does not allow to create a true global constant. However, you can simulate them with global variables. Key, if you do not declare a global variable in the global with the global keyword inside of the function, then you cannot change the variable's assignment. Okay, all right. So if I don't do this, if I don't do that and run this, enter a number 10, the number you entered is 0. Okay, so let's see what happened here. I was not able to update it. Why? I was not able to update it because I didn't use the global keyword on line 4. So even though I put I entered a number, I put in 10 into number, and then I called show number, it was still showing 0. In the previous example before, it was not a good example because I was actually mixing up the idea of local with global variables. Okay, so here's my global variable, right? But I'm not able to update it. It's become kind of like a constant. Remember, a constant is something that doesn't change. I entered in 10, 10 went into number, and then I called show number, but guess what? It didn't update it. It did not update it, right? So that is a way of simulating global variables. Okay. So again, remember here, this is a global variable. A local variable would be something like this. It would be like that's a local variable, right? Because it's only, I can go ahead and use it here only, right? Let me go ahead. So if I were to run this, well, it's not going to make too much sense. So here, enter in a number. I'm going to go put in 20. It gives you 10 because I assigned 10 to num2. So this is, num2 is a local variable in distinction to number on the outside. That is, so it's where you put it that makes. Right? So if you put a variable inside of a function, it is local. If you put it outside, it is global. But if you want to update the global variable, you must use the global keyword, and that is the point. If you do not use the global keyword, you are not able to update the global variable, and that makes it simulate being a constant. Remember, a constant is something that does not change. Typically in programming languages, we designate constants to be all caps, and there's certain times where you may want something not to vary, and other times when you may want something to vary. Okay, so that is my rendition of this section on using functions with Python. The main idea here is learning the function definition and the call. We learned about parameter variables, and we learned how to pass them by position. And then we also learned that they're passed by value, and that means that the original one is not affected. Okay. So other than that, that is my little summary of functions. It's a very good way of organizing your code. I don't know if you can imagine this, but if you have like, maybe if you have hundreds of lines of code, if things that belong together, you can chunk them out and put them in functions and organize your code so that things appear in a more organized kind of way. The other thing that was new and thrown on into this chapter here was the use of the main function. You don't really need to do it that particular way. Just remember that if you do use a main function, you must call the main function at the last line in that particular file. Otherwise, nothing will happen. All right. Well, thank you very much. Goodbye.